presentation started. Okay, so welcome to this learning session. My name is Zacharie Liman-Tinguiri, and I'm joined with Dr. Lewis Thomas. And today we're going to present, can AI be trusted for sickle cell disease education? So this is going to be a very interactive session. And yeah, let me start by mentioning about us. So Zacharie Liman-Tinguiri, I founded the Sickle Cell Knowledge and Information Network. I was born with sickle cell disease. I have an MBA from Cornell, and I was cured from sickle cell disease in 2015. In 2024, I founded the Sickle Cell Knowledge and Information Network, and I'm a former senior AI product manager at Google. And I'm going to hand over to Dr. Thomas, Dr. Lewis, that many of you know from TikTok and other social media channels.
Hi everyone. I just introduced myself briefly. So I live with sickle cell SC genotype, and I've been creating content on social media for the last 9 months or so to educate everyone about sickle cell. This has led to me founding the Sickleverse, which is a digital education platform which helps support the community basically and bring people together to learn together. I've been a medical doctor for over 10 years working in the UK, and last year I left clinical practice to focus on my mission, which is helping everyone with sickle cell to understand their bodies and advocate for themselves. That's me. Back to you, Zach.
Okay, sounds
Oh,
good. Can you see me? Can you see my screen?
yeah.
Yes.
Okay, so I think we just need a basic definition of AI. There are many definitions of AI. I think one definition that I do like is AI is a system that has the ability of performing tasks that typically require human intelligence. And that's the definition that we're going to use throughout this presentation. And I want to say I echo a lot Bill Gates' sentiment in saying that AI and this new revolution that's underway is probably the most profound technological innovation of our lifetimes. There's just a quantum leap. And I want to call your attention to one specific paper, which started a lot of what's going on now, which is a paper published by a team of researchers at Google called Attention is All You Need. So in a nutshell, after this paper, AI became significantly more capable than previous machine learning models that existed. And the paper is super interesting, but what this paper demonstrated and revealed to the world is a method of allowing neural networks, which existed already for a long time and powered a lot of applications that we're familiar with, to be able to understand information in context. And that made all the difference. It is this transformer technology that is changing the capabilities of AI. This architecture is implemented in a lot of applications like ChatGPT and other chatbot, but it's also powering many different applications. So for example, AlphaFold is an AI model which is used in pharmaceutical research because it helps predict the structure of proteins, which is critical to be able to develop new medications. Some of those AI tools are implemented in genomic research, for example, to be able to better understand how genetic sequences affect different phenotypes. That same structure is what enables AI models to be able to work with images, to be able to interpret X-rays, and to be able to generate videos. So this is the foundational paper that has enabled old school neural networks to become infinitely more powerful by enabling them to have a contextual understanding of information. So a few analogies to understand what a transformer does. A transformer is a method that allows a model to understand context. So an analogy that I like is maybe the keyboard analogy, right? So when we take our phone and we swish with our fingers, we're not clicking on every single keyboard, but our phone is able to infer what word we mean. So likewise, transformer models use mathematical representations of concepts to be able to get meaning and contextual meaning. So that is key. So when you say sickle cell, the model is able to understand that because you've used the word sickle and the word cell, you're talking about a biological concept, and then you're not talking about a monk's cell or a prison cell. So that's important to remember. So essentially, that architecture enables nuance, context-aware language generation amongst many different usage. In a lot of industrial or other types of technological usage of AI, we don't generate language. We just use mathematical embeddings that are inputs into other models that do a lot of work. Now, AI is super powerful, as we all know, but it also has, before I jump to the risks, I wanted to highlight something that is going to be important as we continue our discussion on AI. AI is just not one system or ChatGPT. It's actually those applications are an orchestration of multiple models. And that's key for the remainder of this presentation. So when you use ChatGPT, for example, you have many models that are at work, working together to be able to create the experience. There is a model that tries to understand your intent. Based on that understanding of an intent, that model is going to be orchestrated to retrieve information from a database. Then there's another model that is going to encode that piece of information so that it can understand what you're meaning. And then there's another model, which is a decoder, which is going to write information for you, which is going to pass it to another model that is going to apply safety guardrails before your answer is served. And this is a big simplification. In reality, you have more modules, more systems behind pretty much any AI application. Now, so in the next section, we're going to talk about some of the risks inherent in AI, and that will help us understand how we can mitigate those risks. So I'm going to illustrate with one example, which is the Tay incident. In 2016, Microsoft built an interactive chatbot that was accessible to the public, and in a few hours, that chatbot had to be shut down. Why? Because that interactive chatbot was generating racist, xenophobic, anti-Semitic content that was clearly offensive, morally inappropriate, and the system had to be shut down. And the reason why, because that model was trained with content that was collected from the internet and it was unfiltered. And the tool amplified a lot of societal biases, misconception, and morally inappropriate things. So I think one lesson from that to understand is that AI is a mirror. It's not a moral agent. AI systems are going to reflect and amplify what they're trained on. In healthcare, that also means that if AI agents are trained on data that is biased because it does not cover the whole scope of a medical area, or because it embeds societal biases, we can expect that AI to amplify those biases. So I think that's a key lesson to keep in mind. AI is a function of the content on which it was trained on. I also want to highlight another risk, which is the impact of exclusion. That risk was popularized by the work of Dr. Joy Buolamwini. She's a computer researcher, and she demonstrated that facial recognition systems that are trained only on white faces are not very good at identifying accurately Black faces, for example. And even when the system's performance can reach high levels of performance as measured by, let's say, accuracy, the system is 95% accurate. But if it's only trained on white faces, it may be very inaccurate in its ability to accurately identify Black faces, for example. And this goes back to to what we saw earlier. An AI system is a function of the material, the content on which it was trained. And that is true of pretty much any AI system. More generally, all of these risks and challenges inherent in AI are understood as the alignment problem. So the alignment problem was conceptualized by philosopher Brian Christian, which is pretty much the gap between what we want the system to do and what the system is actually doing. And in this magnificent book, if you have not read it, I encourage that you read it. Brian Christian dives deeper in explaining why is it that AI does not do what we want it to do, and what do we need to do to make sure that AI systems reflect our ethical values, our moral norms, and they do so reliably. The very good news is that because we understand the risks of AI, and because we understand the challenges of making AI safer, that also means that we have the tools to make sure that those systems are serving human needs, reflect our values, and are bounded by moral principles and guardrails. So yeah, I know I'm going very quickly. I strongly encourage you to follow up on some of those resources. There's a vast literature out there that analyzes the risks of AI and proposes very interesting solution on how we can remedy those risks. So that leads us to one insight, especially in the context of medicine, which is AI is powerful, but it does not replace clinical judgment. And what we mean there is an AI system can do a lot of things, but as of yet, it does not fully replace human judgment, because human judgment relies on a lot of different sources of information. It relies on the experience of people. It is able to reflect intentionally ethical values, moral principles, and yeah, so we're not there yet. I'm a bit of a utopist. I feel like one day AI is going to get very close to good human judgment, but I think that the road ahead is pretty long. Now, even though AI cannot replace clinical judgment, and I don't want to say human judgment, I think clinical judgment is better. AI can be a powerful tool for clinical care. So, I think the best way to conceptualize it is humans who have good judgment can be assisted by AI to make better decisions, right? Because AI is able to serve, uh, AI reduces the cost of knowledge and information to zero. And when information becomes more easily available in the hands of people who have good judgment, then that improves their decision-making ability. And it's this
Zachary,
synergy that
can, can I just can I just come in here because I had
yes, please, please. Do you want
some
me to go to your
examples.
slide?
Yeah, sure. If you just go back to the previous slide, AI is powerful. I think it doesn't matter anyway. So yeah,
Which one?
the the first one, AI to AI tool, AI is powerful but doesn't replace clinical judgment. Yeah. So, I just wanted to share an example here because I have a few reflections as a medical doctor, which I think will find interesting. And a recent example was one of my friends visited me, and he's not medical and he's an engineer, but very well educated. And he'd recently recovered from having a bad tummy bug. And he was basically telling me how bad this was, because that's what everyone does when they see doctors. And he mentioned that his stool had gone white, and he was explaining the whole physiology and process of his stool turning white, and then said at the end, at least that's what ChatGPT told me anyway. So all I said to him was, that's interesting. I've never heard that before. And as soon as I said that, I could see the fear and anxiety on his face come because he was now considering whether or not the information he'd received from AI was accurate or not, and whether there was something going on that a human would have picked up. So I think this is a good illustration of how most people weigh up information given by AI versus information given by a trained human when it comes to their own health and well-being. Um, so he's fine, by the way. I did reassure him and we talked about it over. Um, can you just go to the next slide now, Zachary? Yeah. So yeah, I think like you were saying, it's all about the synergy between a trained human and AI, and it's using them together so that the limitations of both can be overcome. Because as a trained human, I can apply clinical judgment to overcome the AI hallucinations and empathy to relate to people in a way that AI can't. And then as an AI, it's just able to operate and access information so much quicker than a human can. So it's an amazing tool. Um, Next slide, please. Okay. So I just wanted to put this into context as well, going back to my previous life working in general practice. Um, I'm a generalist. I'm not a specialist in every condition I see. So, for example, if someone with sickle cell comes in and I'm just a GP that doesn't live with sickle cell and have all this knowledge of it, my sickle cell rating overall for knowledge might be 50 out of 100. And that 50 is my confidence in handling that specific scenario. So I'm aware there's much more that I don't know because I've not had that experience and I've not studied sickle cell in depth. So what I have to do in that situation is check trusted guidance. So I have to look up NICE guidelines, National Institute of Clinical Excellence. I have to double check latest recommendations. And I'm doing all of this at the same time as I'm talking to a patient and generating a picture in my head of their clinical context. And all of that together just uses up a lot of time and energy. And AI can speed up that process massively. But the important thing is that I'm not asking AI to replace my thinking. I'm just using it to extend it. So I'm still bringing all of the clinical context. I'm still inputting all of that in, and I understand the risks, so I know what doesn't look right. And all of that I have because I have the 50 rating of a generalist. I have enough sickle cell knowledge to, understand that. So when AI gives me an answer, I can sanity check it, and then I can use that to boost my rating to 100. And that basically allows me as a generalist working in the community or in the emergency department to be able to think more like a specialist and give people that level of healthcare. So that is the best use of AI for that situation. So my other more recent work now is as a content creator. And this is a picture of me in the slide explaining a metaphor to describe a common sickle cell complication, which I'll let you figure out what I'm explaining there. But basically, AI helps me so much as a health educator that has medical knowledge because I can import these ideas for metaphors and examples into it, and I can check my understanding very quickly, and then it helps me refine the explanation so that it matches with the physiology, and I can craft it in a way that people actually understand what's going on. But one of the biggest limitations that I would mention about using it for this purpose is that because there are still lots of gaps in sickle cell research, a lot of the questions that my audience will be asking, there isn't a clear evidence-based answer. And when I input that into AI will often fill the answer with a gap that sounds convincing but isn't actually true, and that's the hallucination. So a lot of the time, what I end up doing is spotting that, and I'm going back and forth with the AI because I know what it's saying doesn't make sense. And that process for me is actually helpful because it increases my understanding of the topic even deeper, and then I can create a better explanation for patients. So yeah, overall, I would say that AI is extremely useful when it's giving you trusted medical knowledge, information based on trusted medical knowledge, and it has its guardrails in place. And then if you have the human oversight as someone trained in that specific area, um, all of that together, it's just so powerful, and it's a no-brainer for me. So I think this is exactly what we're sort of channeling into the SickleCellPedia tool, um, which makes it so useful. And Zacharie is now going to explain how some of the other limitations of AI can be overcome by anyone.
Yeah, so in the next few minutes, I'm just going to offer some helpful tips that can help you use any AI tool more effectively. So I think the first one is knowledge grounding, right? Any AI tool you use is using a source of knowledge. So a strategy to use AI more effectively is anchor the AI's responses into credible sources. And you can do it with a lot of tools. If you use Notebook LM, you use ChatGPT, you use Claude, all of these tools allow you to import your own trusted sources of knowledge or restrict the answers to a specific domain of knowledge. So that means that you instruct the AI to anchor the answer in a specific corpus that you trust. Also, when you prompt an AI, you can assign the AI a role. And because it's context aware, if you tell the AI that it's a researcher, it is going to be more factual in its responses than if you don't give it that constraint. So a researcher follows a certain process, and you can prime your AI to follow a given model in terms of retrieving, analyzing, and processing information. To reduce hallucinations, you can also restrict the AI and force the AI to cite the sources of the claims that it makes. So that way you can verify what the AI is saying. So knowledge grounding, I think, is your most effective strategy to reduce inaccuracies by AI system. When you are designing an AI system, there are a lot of features that you can use to make those systems more accurate. So, for example, we discussed personal constraints. You can use multi-agent auditing, where there are multiple AIs working on the same answer. Those features are already available in a lot of commercial tools. So for example, when you're using any of the commercial models and you're in thinking mode is in effect having multiple models review the answer before it serves them to you. And you can see like the chain of thought. Sometimes the AI starts writing and then it erases it because on auditing itself, it was not happy with the first answer. So that's an easy way. Use thinking mode versus fast mode. If you're designing a system from scratch, you can define settings like temperature. Temperature is a setting which directs your AI system on how rigorously it needs to understand the context. On a low temperature setting, the AI is going to be super factual. That's the setting that I prefer for medical application because it forces accuracy. It discourages the model to have loose interpretations of concepts or context. On a high temperature setting, AI becomes more creative. It's better for poetry, brainstorming, exploration, but you also invite more hallucinations. So those are design principles that you can incorporate when using an AI system. And in building our AI information chatbot, SickleCellPedia, that's precisely these strategies that we implemented in designing the tool. So it's a RAG agent, and that means that we limited the AI's answer to a knowledge base made of medical textbooks, peer-reviewed articles, and credible medical websites. So that means that the answers of the tool are coming from sources of information that did go through a validation process. So that's one strategy. In terms of instruction, because we want the medical information to be easily accessible, we are instructing the model to respond in plain language. We restrict the model to focus only on sickle cell disease. Only answer when the model is reasonably confident that the answer is accurate. And we add safety guardrails in limiting what the model can and cannot do by, for example, require that the model does not offer medical advice. Why? Because medical advice requires clinical judgment that a single turn chatbot cannot achieve. Other recommendations, use industry-leading models because those models are more capable. Use chain of thought models. So in your preferred model, that's the thinking mode or the advanced mode. And then for any medical application, use a low temperature setting and also implement feedback loops. So for example, in SickleCellPedia, if you're unhappy with an answer, you are able to provide feedback, which can help us amend the failure of the model. So if a model says something that's factually false, we can add a source of information, we can change the system prompt so that the model does not repeat the same error. So that's kind of how we designed SickleCellPedia, and these are screenshots of the tool, but I encourage you to go on our website, SCKIN.org, to use those tools themselves. And we connected that model to a website and to WhatsApp. And currently we observe that most of our traffic, most of our questions are coming from WhatsApp. And I've included a screenshot of examples of answers in both platforms. So I'm going to pause there. I think we talked for more than we wanted, but it's a massive subject. And we would welcome any questions that you may have.
Hi, this is Louis Su. Congratulations on setting up all this, and wanted to check whether the medical textbooks, for example, you would regularly update them so that you don't use something that's too old, you keep up with approvals and so forth, and then whether some of the responses would also tell you this is available in UK, this is available or not available in Saudi Arabia because of what's what's approved by the regulatory agencies and stuff like that.
This is an amazing question. Thank you, Dr. Su. So with respect to the accuracy of the ground sources, we have to rely on experts to give us feedback on what's current and what's not. So I'm happy to announce that Dr. Su has kindly agreed to help us make sure that our knowledge base reflects the greatest and best information available. Because I am not a doctor. He's a medical specialist who has deep expertise in sickle cell. So he can guide us in terms of what to include, what not to include, because AI needs to be selective, right? We have to include the best sources, not every sources, the most trusted sources. And as science evolves, this is a dynamic process. New knowledge gets created, old knowledge becomes obsolete. So the underlying grounding of our tool needs to reflect that. With respect to the second question, which is the localization of the information and the context, currently this tool that we have does not have the capacity to distinguish between what is considered appropriate in different clinical settings. Because as you all know, I mean, medicine has traditions, local clinical contexts vary because not all the same medications are available, not all the same hospitals and healthcare settings have the same resources. A patient or a physician in Africa is not in the same environment as a patient or a physician in Tennessee, and so on. Current version of SickleCellPedia does not, but we are working on a more capable tool that will be able to introduce those clinical nuances, those context nuances. And it's just going to require a lot of work, but it is possible to get to a state where the answer is contingent on the healthcare setting of the person asking the question. And I also feel that going back to what we're discussing, which is who is using the tool, and Dr. Lewis was discussing that in an ideal world, we're going to have different AI systems that are optimized for the use of different audiences. So a decision support tool for a clinician is going to be different from a information tool for the general public.
Thanks. And maybe that could use a chat feature, like a follow-up question.
Oh, can I,
Uh,
it's Paul DeMonico. I just unmuted myself. Is it possible for me to make a comment, Zachary?
Yes, yes, absolutely.
Okay, and I want Lewis, I want to thank you for bringing up the example of the individual who used the tool and found he might have these white spots or whatever the example was. Um, I think what you said, Zachary, basically about diagnosing the person who's asking the AI a question is really important. Understanding their level of understanding. You can be a physician and not in a general setting and not know anything about sickle cell disease. Although you're a physician, that doesn't actually qualify you to be an expert in sickle cell disease unless that's your training. And so for an AI tool to be useful, it has to understand not only the context of the question, but of the person asking the question. And how is it that it gathers that information to say, oh, this person's an expert. Oh, this person's a novice, and they're in a position of trying to make a good decision. How do I help them take that journey, knowing who they are or where they're coming from? Over.
Yeah, Paul, you're 100% right. I feel like this is super important, especially in the design of the tool. It needs to be aware of who is using the tool, who is using the information, what level of understanding uh, they have. And yeah, fully agreed.
Because we've
Fully
developed
agreed.
tools that when we use those in the US, the physicians know it's an aid. But aid slash diagnostic is in the eye of the beholder. And if another group of people see it as a diagnostic, it is therefore effectively a diagnostic and needs to be validated a different way. So it might be very interesting to take a look at how regulatory bodies are thinking about machine learning, AI assisted diagnosis to understand how they think about that context. Over.
Yeah, no, plus one. I think this might be a longer offline conversation.
Yeah, sure. Absolutely. And I'm done.
So yeah, no, but maybe for some context. So I do work with a team of researchers in Europe that are part of the RED network. Uh, and it's interesting, like if I take France, for example, AI tools are regulated as like very tightly regulated. So you need to have special permissions to be able to deploy AI systems. And those AI systems have a lot more constraints into how they can be built than in other jurisdictions. So, for example, in Europe, if you're building an AI agent, there's a strong preference for using a model whose parameters are interpretable, which in the context of the US is not a requirement um, for AI systems. There's also different regulations in terms of handling patient information, patient data. So a lot of European legislation requires that the data be physically hosted in Europe. And in the context of healthcare setting, that data needs to be ring-fenced um, from other types of data, and there's clear requirements on how it can be accessed. So I agree, fully. I can give you a little bit of an anecdote that maybe can illustrate the vision of the role that AI can serve. So, I mean, one of the physicians that I've known for a really long time, and he's probably known me ever since I was born, is Professor Galacteros, and he's now retired. But in his office, he has a fax machine. And on that fax machine, you have doctors from all over the world. You can think of doctors somewhere in the Congo or in India who are sending faxes about specific patient cases, sickle cell patients who need that expertise. And he reviews those faxes and he responds. So clearly, people recognize the expertise, are reaching out to him cross-border to solicit his perspective on that. And I feel like when you look at elite elite sickle cell doctors, those who have transformed our understanding of sickle cell, made a lot of contributions, they are a very scarce commodity. I feel like in my vision is we can successfully leverage the power of AI to make that expertise more universally accessible, because to train a physician, it's a massive amount of resources, right? It's decades of schooling. Then you have to add on top of that specialty in one disease sectors. And when you look at the ratios, there just aren't enough knowledgeable medical specialists able to properly treat the 8 million or so patients that have sickle cell disease all over the world. And it's this synergy between human knowledge, elite clinical judgment, and AI that we can hopefully make that expertise more readily available.
Thank you so much, Zachary. Really appreciate all of the knowledge you've shared, and especially the basis of just helping to understand the different models of AI and what's available. I know some of the considerations in talking about is just safety, I think, is a lot of the considerations we always hear. Can you talk a little bit, or at least some thoughts there of just things we should be mindful as, leaders of organizations or users, of course, as well, and things we should just be mindful of, any additional cautions we might have, especially as we're putting in information into these. Because we help train them, right? And I know that that's been some concerns of like how what we're putting into it is continuing to train other systems.
Yeah, no. So as individuals, learn how to use AI better. Learn how to verify the validity of the information that's generated by an AI system. As leaders of organization, use existing frameworks, methodologies to audit and ensure the reliability of the AI systems that you deploy. So, for example, auditing responses is one feature. You have established frameworks in terms of benchmarking the accuracy, the factuality of AI systems. So you have to think in frameworks and in guardrails that can be implemented to make those AI systems safer, and then creating feedback loops where the information is ultimately validated by humans so that non-factual information is identified and can be remedied. Now, that being said, there's also a lot of the field is evolving like so fast that there's a lot of improvements. For example, when you benchmark factuality, not necessarily in the healthcare setting, and you measure hallucinations, models that are commercially available today, Gemini or GPT, hallucinate at a quarter of the rate that the first models did 2 years ago. Because in the same time frame, those models have 10 times more parameters, so understand more nuance, they have more knowledge, and they have better and more effective out-of-the-box guardrails and mitigation. So in short, learn how to use AI better. Science technology is improving at a rapid pace, and implement known and existing frameworks to ensure the reliability of the systems that you do deploy.
Wonderful. And I know we had a wonderful session on AI at our United Action Forum, which of course we plugged the Peer Learning Exchange while we were there. But I know that something also that was mentioned, and perhaps you could give some insight too of, I feel like there's a lot of things being generated and built and not necessarily communicating with each other that maybe have some cross functions. Is there any thoughts or hopes or aspirations on what you're hoping to integrate with your tool, for example, or what we can look forward to of maybe people that have ideas that maybe don't want to build a tool, and what they can forward to in that regard.
Oh, sure, sure. We are a very small shop. I think I'm happy to partner with any organization that wants to use our tool. Anyone who has good ideas on how to improve the tool, I think that we're always on the lookout for it. I think when I stare in the future, I'm very hopeful that one day tools like mine will become obsolete by virtue of technological progress. And I think I can already see it, right? So, for example, in the past few months, there's a paradigm shift towards MCPs, right? Model context protocols, which allows us to define frameworks that enable out of the box tools to use our quote unquote recipe or secret sauce to use AI effectively. So in a future state, for example, people who author the guidelines for the American Society of Hematology, Ash could, I'm just speculating here. I don't know anything about what Ash is intending to do on AI, but hypothetically, Ash could release an MCP, which will be able to have a knowledge base of what is considered standard sickle cell knowledge, that will be able to have protocols on how different individuals, as Paul mentioned, based on their knowledge, would be able to use the information. So there's a lot of progress there. But in short, if anyone wants to use our tool, please do so. We're always looking to partner with other organizations. Please do reach out. And I'm hopeful that this individual adaptation will become obsolete very soon, because we'll have frameworks to be able to efficiently create protocols that any AI system that is not necessarily encased in any specific platform will be able to use to make sure that reliable and useful information on sickle cell disease becomes universally accessible. And that's our mission. So don't hesitate
And what
to
a
reach
great
out.
mission it is. Thank you so much, Zacharie, and Dr. Thomas, of course, for joining us. And just taking the last few minutes just to remind everyone, I did drop the link in the chat for our feedback survey for all of our peer learning exchanges. All of our peer learning exchanges are really just our ability to bring those who are already working in the space, doing the work, have wonderful lessons to teach us and help us bring the expertise that they bring for the different sectors, because it does take all of us, right? That does take all of our different work and our different expertise to be able to make progress in sickle cell. And it's so important for all of us to keep educated and aware of what's happening in the space. And especially, and I always famously repeat the line of, AI will not replace us, but it will replace those who use AI with those who don't, and those who don't know how to use it. So these are important tools for all of us to learn and be able to maintain. We're hoping to be able to offer more sessions. So please fill out the feedback survey for any future ideas or future sessions. We're happy to stay a little bit longer on the line if anybody needs any contact information for Zacharie or Lewis to be able to access their tool or anything future. And of course, as always, all of our peer learning exchanges will be available via recording once we've just shortened them and compiled them, so that way they will be accessible and shareable in the future for anybody who would like to review them. Any final thoughts?
I thought this was really excellent. That's all I would say. Nice job, Zachary. Nice job, Lewis.
And we're seeing requests for your contact information in the chat if anybody would like to drop their emails, or if they would like to at least they're always welcome to contact us at the coalition, and we're happy to forward contact information that way as well.
Just to say thank you. This was so awesome.
And Eunice, you had the question of about warriors,
Yeah.
perhaps like learning, and I know that was a discussion we had at there a little bit in the Action Forum. We were talking more symptomology, but there is some talks about learning and training there too. But thank you so much for everybody who joined us, and if you want to hop off, thank you so much.
Thank you so much. Enjoy your It's morning on your end. For me, it's evening. Bye.
Yeah, it's a nice sunny afternoon here.
Oh, is it?
It's lovely.
Oh, I see a question from Marjorie, wondering if the questions asked inform the way the information is presented. I guess it depends on the model, right? Some of them have specific ways to respond, and others just have like a format that they kind of respond in.
And the same question will have different answers if you ask the same model, because large language models are stochastic, they're not deterministic. So try it. Ask the same question of the same model 5 minute with a 5 minute interval, and you're going to get slightly different answers.
Oh, really?
I would say as well that the way that medical professionals ask questions is a lot different from the way that patients ask questions. So I think that the AI is actually really good at picking up on the level of someone it's engaging with just from the way they input information into it.
Okay, I guess then the next phase of the question would be, sorry, I had my camera off, would be then if that question is answered different ways, does then, again, I guess it depends on the tool, then the answer become maybe more detailed? Do you see what I mean? Or more in depth because of the frequency at which it's asked? And that's on one end. And do we then maybe use this tool to then inform providers that, this is what seems to be coming up more? Maybe we need to, because I can see it being a two-way street. We need either more information, need to educate people better, or get this information out to the community. I was wondering if the tool was used in that way or potential. And I know we're at time, and Ivy knows I can go on forever. But I left my email in the box, so maybe we'll communicate in that format. But thank you so much for a great session.
Thank you,
Brief
Marjorie.
plug on that. Dr. Lewis and I are submitting an abstract where we want to dive deeper into that question, which is what is the community asking? And that can potentially identify some knowledge gaps. We're also very curious to understand what are people asking of an AI tool that they may not necessarily ask
Ask their physician.
their doctor, their
Yeah.
physician.
Right. Yeah.
And those are,
Yeah.
And our intent there is really to understand and maybe to provide some cues as to what information can best be served out there. So yeah.
Yeah, that power of bidirectionality is amazing. Well, again, thank you guys, gentlemen, for a wonderful presentation, and looking forward to doing some work with you guys in the future.
Awesome.
Yeah.